Alright, so we're moving into the last section of Chapter 1, and we are still talking about describing quantitative data. Our goal today is just to choose the most appropriate measure of center and spread with a given setting. And so I want you to be thinking about through the lesson, an outlier affects which measure of center and why. So at the end of this lesson, you're going to be asked to answer these 5 questions about measuring center and spread. And take a minute, look over them. Some of them are a little bit of review of what we did yesterday, so make sure you're understanding those, and we will move forward. Our only vocabulary word today is resistant, so we're going to be talking about that throughout this lesson. So just a quick review of yesterday's lesson. We have things that measure the center, which is the middle of the data. We use the mean, and we call it the average. So we're talking about an average value, whereas the median is the middle number. So it doesn't take into account any of the numbers values on the left or the right of it. It's just what is the value of that very middle number, and it's a position. So the mean is a value, the median is a position. And then we have measures of spread. We've talked about standard deviation, and that talks about the measure of spread about the mean. So we take the mean and we look at how far away is data from the mean. And then we have IQR, which measures the range, so we're talking about the smallest to the largest, of the middle 50% of the data. So we're not going to worry about the outside 25%. We're just looking at what's inside that box in a box plot. And then we have the range, which I put in parentheses because we're really not going to use it a whole lot as a measure of spread in what we're talking about today, but it does exist. And it measures the range of 100% of the data. So the smallest to the largest, taking into account all data pieces. Alright, so I just want to draw your attention down here to this histogram. And what this is it's salaries of geography graduates from the University of North Carolina. And so we find out that the average, meaning the mean, is really high. Whereas the median, or what most geography graduates from the University of North Carolina, what they make is a lot smaller than that. And so what's happening is, if you know anything about basketball history, Michael Jordan graduated from the University of North Carolina in geography. And so when you look at a histogram, this is all the other graduates in geography and their salary, how much they make. And here's Michael Jordan way over here. And so by taking into account his salary, which is obviously really high from being an NBA superstar and from all of the endorsements that he has, it's going to pull that mean a lot higher than what the rest of his peers would make as a salary. And we're going to do some exploration with that tomorrow in class, but I just want you to kind of get this idea of what is happening when everybody else is here and I have 1 or 2 people that are way over here. What is that doing to my data, and how do I accurately represent? Because University of North Carolina could go out and recruit for their geography program and say, hey, your average salary is going to be this, when in actuality, if we took Michael Jordan out of it, having nothing to do with geography, the average salary is going to be a lot lower. So when I look at a histogram or any sort of data display, if the data is symmetric, the mean and the median will be approximately equal. If it is skewed right, meaning that tail's over to the right, the mean follows the tail. So if the tail's to the right, then the mean is going to be higher than the median. And if the tail is to the left, then the median will be higher than the mean. And we're going to talk about this idea of resistancy. The median is resistant to outliers. And what that means is that when there's an outlier, because if you think about the median is the position of the middle number. So it doesn't take into account the other numbers' values like the mean, because the mean, we add them all up. So I take into account the value of every single data point and divide by how many there are. So if there's a really high number or a really low number, then that's going to affect the mean because I'm taking into account every single data point. Whereas the median just looks at the middle number. So the largest numbers and the smallest numbers can be really, 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 really big or really, 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 really small. I don't care about their values, I only care about position. So when I have outliers, the median is going to be more resistant to those. Alright, so I want you to take a minute and look at this cartoon and see if you can understand what's going on. So go ahead, just in your notes, I want you to analyze what's happening, look at the cartoon, look at the dialogue that's happening, and come up with why this is a math joke. We will come back to this. Alright, so we talked about outliers can impact my data. So like with Michael Jordan, I could advertise that geography majors from the University of North Carolina make this large amount of money when in actuality most don't. So how do I accurately represent data? Because that's a way that we can create data that's misleading, is if the mean or median, whatever I use, is not accurately reflecting the most of the data, so the general population. So when I look at this, when should I use mean? When should I use median? Because those are my measures of spread. When should I use standard deviation? And when should I use IQR? Because those are the 4 measures of center and spread that we're going to be talking about that we use in different situations. Alright, so this table just kind of sums up. I'm going to use mean and standard deviation whenever there are no outliers. So we're talking about a symmetric distribution. And the reason is because the mean and the median are pretty close together. We want to use the mean and the standard deviation as much as we can. We want that to be our default. However, as we've seen, when there are outliers, that's going to affect the mean and the standard deviation and make it no longer a reliable data source. So that's when we resort to the median and the IQR, because they are resistant to outliers, meaning the outlier does not affect them as much as the mean and the standard deviation, because in both of those cases we're taking into account the value of all data points. So if I have an outlier, that value is going to impact my result, whereas the median and the IQR, the median is that position, the middle number. So it doesn't matter the value of the numbers outside of it, it's just the position. And then the IQR is just the range of the middle 50%. So if I have outliers, then I'm going to ignore the outside 50% and just talk about, hey, 50% of the data is between this and this. Alright, so those are all of our notes today. So go ahead and pause the video and have an interaction. So summarize what we just talked about, write down any questions that you have about measures of center and spread and when to use them, and then also write yourself some notes. What are you going to need to remember when you go to study? And I'll see you tomorrow.